two reasons for that. The main important one, our ExVR is a bit outdated now. Most problematic issue is we can't use modern HMD. When I say modern, I say after a decade, Oculus Decay 1. It was somehow possible, but very, very tedious. Updated graphics, it was a very old, it was just basic OpenGL code rendering in Python. So it was possible to do fancy stuff, but quite complicated and necessary. You need a lot of expertise for that. And the ergonomics could be improved quite a lot. So can you just no, it's me. I will do that. Okay. Okay. Unity has been used in many labs because it's easy to create simple 3D scenes, and quite a lot of researchers are using it for creating their own experiments. And we will also increase the potential audience, not only expert, not a technical expert. Also, the need for better performances is also quite a thing because, yeah, on Python, it was you can't do many real-time things, especially with very 3D demanding scenes. And obviously, the integration of new devices, we need to make that integration easier. And the idea behind that is to be able to create more complex experiences. We see during the showcase, or like using MRI with external tracking, using external camera for doing a body scanner, or using robots, using real-time physiological data. So, what is ExVR? It's a solution for creating and executing 3D or not experiments. So you don't specifically need to use VR. You can render classic 2D task. And it's a combination of two software. A designer that with a portfolio guide, so it's made in C++ with Qt. It's very similar to CyclePy for this part. And the second software is made with Unity. It's an experiment launcher. It basically is just quite an empty program, but that will, from the output of the designer, generate at runtime the experiment. So you will be able to play it. Here you can see the designer part. So you can recognize a few things from CyclePy, like the flow control at the top and other components to the left. I will detect that later. And here you can see a capture of the experiment launcher. Okay, so one of the most the selling point of this software is to make it easy to share experiments with others. Once you have designed your experiment, you can just export it. It may make it's super easy, and anybody else can just open ExVR and load the experiment and have the same result. Also, you don't need to be a coder. You don't need to say be able to write scripting. You can just make quite a lot of things only with your mouse and your by drag and dropping stuff. And also with the visual scripting part to help adding more functionality without scripts. So we will detect that later. And the workflow is very similar to CyclePy. We have the same routine, loops, condition, components. The idea behind that is the same, but I many improvements to improve what we can do. So it was developed at TPFF. Yeah.
It's optional. Like if you want to script, you can.
Yeah.
But if you don't want, you don't need to.
Yeah, sure.
Can you not script in the beginning, like do a GUI and then generate one script? Like if you do by interface.
No, when I said scripting, it wasn't, you need to use the interface, not as, I know you can use PsychoPy without the BOI, but it's not the same idea. When I say scripting, it's more about executing code during the experiment to do things. It's not about generating the experiment with scripting. So
that thing doesn't happen.
Yeah, no, because I think the interface is good enough to allow you to do what you want without having to do that with a command prompt. But it will be up to you to see that. Yeah, the scripting part is more about linking over components, creating stuff in real time, computing data, processing data for displaying things. Whatever you want, in fact. It's just we have components that will execute mostly C# for now, but can be Python in some future to just improve what you can do. If there is no component that can do what you want, you can just create your own using scripting. Meaning you will be able to keep using the same software. You don't have to recompile it, but you will be able to do more things. So this development started 5 years ago. So I think now it's still quite Polish. It has been stable for quite a long time. But we only focused on the Windows platform because the main point is still using VR, and it's way easier to do that with Windows. I was using SteamVR as a software for interfacing with SSD. So you can use Oculus or Vive devices, Windows Mixed Reality. So meaning around 95% of every VR SSD. So at this time, it had been used for dozens of experiments and many demos inside LNCO or even for international collaboration. We have in Stanford and West Virginia. And it has been funded by the DeFi Open Science Fund in 2019. So meaning it became open source. So anyone can just download it and from this GitHub link and use it. And we made public builds for people who don't want to compile the whole thing. So you can just download this, extract it, and play it. That's what you will do later during the answer. Okay, so I will now showcase a few experiences we have done in the lab. In no particular order, it's just to show various things. So let's start with a VR memory navigation task. We are using full body illusion. So it's a classic memory navigation task in some arena. You have to gather object in an encoding part, and we give instruction with videos. And at the same time, we are using a Kinect for tracking a ball with a stick and for doing a backstroking. So for doing the full body illusion. Quite a signature move from our lab. Okay, so here you can see small video. So this one is from a third viewpoint. The person has to get objects. After once it's done, there's a recall part, so you have to guess where the objects were. But between two sessions, you can have this. You have this full body illusion, so you can see the green ball. So basically, it was the experimenter with the stick stroking the back, and so the participants were able to see his back being struck from behind, and we had delay. So you have synchronous and asynchronous condition. So for making this illusion. So that's from Emmanuel De Falco. Okay, I will now go with this VR MRI VR briefing agency task. So this experiment has been done in several environments, in our lab, in I think in HUC, and also in the MRI. So the main point is to process real data biopack data, so briefing data in real time to modify the experiments. So what we'll do, we'll get the briefing data, and we will modify from this data. I will modify the mesh in real time to give an illusion of briefing. So you can see here we have the belt, and you can see the mesh being deformed. So what I was briefing. So, and we were doing that in the second way with antiphases and many more conditions, but we show the main condition here. So after you have to say if it looks like your own body. So it was from Sophie.cap. And yeah, you can see top left, the same experiment, but in the MRI at Campus Biotech. So, so now we have this VR memory task with object recognition from Natalie Meyer. This one is was using hand tracking and gaze. Okay. And then we were using the gaze to increase the size of objects we have to recognize. So by using the hand tracking, you can, yeah, it's a first-person task. And we are using hand tracking, the lead motion to do the hand tracking of the avatar. And from the gaze, we're able to look at objects and to recognize it. So it's still a memory task, and in medicine, you have to say later if the object was in the room or not. So that is a very old video. I don't have many of these experiments, but just to showcase a little bit, yeah, the avatar tracking. Okay. We have another MRI VR memory task. We have tracking, still with Natalie Meyer. So we were using the here you can see Alice's camera. So they were MRI compatible camera. We used to track the hands, and so we can do some very light movement in the MRI. Yeah, you have to avoid moving too much in the MRI, but you can still answer question or doing small tasks like this. Okay, so it's still a memory task, and we were doing hand tracking as a specific task, and so oops. Okay. So we had several viewpoints, first PP, first PP, and we alternate different scenes in the forest, in some house, some other lab room. So it's easy to switch between different scenes. Also, we can do VR perception manipulation. So this one is a bit particular. It uses a reeducation device called TR Trainer, so you can move your body, and it uses a gyroscope. So by getting this data, we can redo the same movement in VR, but by using a mirror, we are inducing some distortion of the movement. So the user has to reach a point with his body, but the mirror was giving wrong indication sometimes. So, and we are trying to get all of the user was trying to compensate movements from Estelle Palway. We can also do very classic 2D tasks. So this one is a biomotion task with workers. So we can just easily show sliders, and in VR, we are still doing that in 3D, but if we render that on the 2D screen, it will just give that. But the real thing is that. This one is from VR. So we are using this back stroking robot in synchrony and asynchrony. So the idea was to show videos of not videos. We are creating videos from dots, 5 containing dots, and we had some randomness to it, and people had to say if it looks like a human walking. And by depending the answer, we just modify it. And you have breaks with API stroking. Okay, so now I will speak about this VR out-of-body task with body scanner. So I've been using a system with 10 Kinect version 2. The idea was to get the data from this Kinect, to calibrate them in a unique cloud, and to display it in 3D through the HMD. So basically, you were able to see your own body in real time using this system. So this task was from some user, and the idea was to you will see in this video. So he's laying down on the bed, putting back his HMD on his head, and we are doing some camera transition to give this feeling of out of body. And the fan, the same fan, was used for giving a sound reference. So this one is our old system. I have a new one now, but I will not showcase it today. And if you want to see from another viewpoint, so we have the first person view. It's exactly the same thing. Okay. Also some VR memory navigation task with flags. So it's still in some arena memory task, but in this one we have to get through flags and to always frame by pushing a key or by using hand tracking. And after we have to guess where we were. So if I move a bit forward, after we are showing the different images and you have to guess where they were. I think I was wrong most of the time here. Yeah. Okay, and this one was another version, just to showcase that we were doing using a real rope with hand tracking. We try several things with hand tracking using a Kinect with a real rope, and this one was just with the leap motion. So just detecting this one. So the idea is just we can get from many different devices, and we can process them to do specific actions. And now we another out-of-body experiment from Simpin using our front-board example platform and the body scanner. So it's the same second version of our body scanner system. So you can see a participant being given instruction by Simpin. So that is the first person view, but we'll see in this other video what is seeing. So the right part is the first person view and the second part. So you don't see it very well, but it's using this platform. So we are inducing movements and we are counterbalancing it in VR so the participant can't see that the platform is moving, but this can still feel movement, and we are moving the camera to match this moment or to do that the other way. Okay, internet connection is bad. Okay, so after this few examples, I will now describe a little bit the software. So we start by the designer user interface. So you can see designer started with some big experiments. We'll start with the flow creation part, or at the top. It's where you will just design what will happen. You have a start and some ending. You can see the green containers. There are containers for condition. I'll speak about that. So when and the right part is for information about what you select in the flow control. So you can select routines and loops. So I will detail them. So when you click on the black dot, that is a new experiment. It's totally empty. You click on it, we can build routines. So they contain conditions, and these conditions are associated to duration. So a condition can contain many different actions. These actions are basically components. They can do quite a lot of different things. But the idea was to link them with loops. So different loops will help you define the different conditions you have in routines. So, okay. So by setting, by defining the setting, you can say that a routine will have this many different conditions, and each different condition you can put different things. So I will start the video here. So you can see a quick design of a skeleton. So you can create this routine quite easy. You can move them around. You can create nested loops like this. So when the idea when you create a loops, it will go through the whole content and go back the number of times you have set as a number of iterations. So okay, if I do that 2 times and this one 3 times, I go here, do 3 times this one, going back here, and we're going 3 times this one, and going back here, exactly like the copy. So after we can rename them easily, doing more, giving them more sense. Okay, so here I just rename the different routines. So that is just a classic skeleton. We have a one phase, session scrolls, we show the stimuli. After we have a questionnaire and some break between the two the blocks, and at some point it will reach the end. So here we are. I will just go back a bit. So here we are in the questionnaire loop. We just define several sets. So question 1, question 2, question 3, meaning it will create as many conditions we have defined set in this routine. And each loop will mix their set to create the condition, meaning here we are outside, so we only have one condition, so default one. Here we have only, I think, we will see, I don't remember. Okay, I just edit here. Oh, I will detect that later. I think I have a slide about that. So next part is the components. You can create them on the bottom left part of the software. In fact, you can move any part to customize your interface, but I will only speak about the default interface. So you can create your components here, and you can open them. It will generate their own interfaces for setting their parameters. So we have many components for doing a lot of things. We have components that do camera movements, follow you to control the VR camera, to use as a first-person camera for an avatar or third-person one, to create complex movements like we did for the out-of-body experiment. We have network components, classic one for writing to UDP, reading UDP, serial port, parallel port, quite useful for synchronizing with our device, like EEG or to writing to some vibrator or stuff. We have logger components. They are very important for saving the data of the experiment, to save answers, to save data from devices. We have, I will detect that later, but we have automatized logging using this global logger, meaning you don't have to, if you don't want to do it by hand, it will just save every data you have defined by itself. Meaning you can just save everything you want, and just in case you forgot something later, oh, I'm glad I just saved this data. Okay, we have UI, so a slider system for answering. They can be continuous or not. We have buttons. You can define your buttons grid for answering. Well, we have environment stuff like creating lights, post-processing the images, showing the sky, can be skybox, color. We have an input device. If you need to use a mouse, keyboard, trackpad, can be anything. And we have 3D model components. So classic cube, sphere, and procedural shifts. You can load some cloud files. You can use the flagpole we saw in your experiment. You can load human avatars, link to the Unity asset bundle. That is very important. It's the way to load components you have made in Unity. If you are used to, because this software is not made for replicating it. You don't specifically need to use it, but you can define your own scene in Unity, create 3D stuff and having a nice rendering like you want, and you can save that into a specific component. It's quite easy, just a script you have to call. It's very welcome, and you create this asset bundle file. And this file you can load it at runtime in XVR to load your scene. Basically, it can be a room, traffic, avatars, or various objects that we saw in the memory task recognition. Every object was an asset bundle. So by separating them in asset bundle, you can make it appear when you want. So you have also resources components, meaning you can easily from your. So we'll speak about later about the resource system, but you can easily link your resources to other components, meaning we'll see that later. You can display images, text, resource, videos easily. You have the C# scripting part, so you can create a very small C# function in the interface, or you can load a hierarchy of C# scripts from your resources. Meaning you just load add several scripts. You just need to follow one inheritance class to be able to interface it with XVR, but we'll detect that later. And we have different viewers, something for blading, for fading and blading the view. So it's nice for transition, a classic fixation cross, image, text, webcam, video. So when I call it viewer, there are components that follow your gaze. So meaning it will always be displaying in front of you, or you can we have a setting to decide, oh, I need this to be displayed in a 3D world. So if you want to do a 2D task, you just follow your gaze, and you don't even need to take care about the calibration of the HMD or anything else. We have obviously other sources. Can be what's the name again? From when you choose the source in 3D space. Thank you, SpaceX. And we have many acquisition devices. So by the BLO pack for getting EEG and breaking. We have Kinect. We have Crisis, the one we are using in the MRI, and quite some other one. So, and that is only for the fully functional components integrated in the public grid. Maybe some more will come later. Yeah.
If you have an asset bundle with many objects inside,
yeah,
are you able to reference this many objects inside your tool?
By default, it will instance the full hierarchy, because if your asset bundle is defined from a prefab from Unity. So if you give your prefab hierarchy name and you import it as an asset bundle, by default it will load everything. But you can just say, oh, I just want this sub object from the hierarchy. Can happen.
Yeah, but my question is, if you have some processing to do on the XVR part,
yeah,
and you have edited your scene in Unity with many objects, and you don't want to export each object as a single asset bundle.
Yeah.
To export everything as a big asset bundle, and then working with that inside XVR.
It really depends your goal. I think if you want to be able to use the subject in a separate way to display them, or if you only want to display a big thing, it's maybe a trade-off. You can decide to put everything in one thing. But for example, one important thing, it will not be able to load custom script you have made. There's another way to do that, but basically it's more for content, 3D content and stuff. But if you have made custom scripting, you can import them later as a C# scripting and add it to the scene. But it's a limitation because you can't the build version of the ExP launcher can't know about what you are about scripts. He has no idea. It wasn't compiled with it. So you need to be able to compile it at runtime, and after you can just link them to your asset bundle. So basically, most of the time you do your thing with Unity if it's really stuff, and once you're happy with it, you can import it, you separate your script using the ExVR way. But it can be it's a bit different, but it's not very difficult. So now we are going to the selected condition content part. So
work it either to C# or the other. What do you gain? What's the advantage of importing your Unity here?
Because you don't have to recreate the whole code for generating the scan, for playing it, for doing the randomization. The tedious part is done with ExVR. You need just to fill it with content. But you can define very complex randomization using the loops. You can you have a very powerful logging system. You have the resources manager that helps you in many ways. So that's the true value. It's not mean. Let's say you have a database of asset bundle for a lot of different objects. You can just decide to create the logic in ExVR, and when you do, it's quite easy. You don't need to load Unity. You don't need to start it. But yeah, if you want to do some very complex things, you may want to do that in Unity first. It really depends, in fact. But I don't have many users using Unity now, and most of the previous experiments were done. Me, I was using Unity to create different components, so we don't have to use Unity later.
So, for example, you will have your Unity scene, and then you do all your trial structure, block structure, interface with eye tracking and others through this software.
Yeah.
If I may say it otherwise, Unity will remain the job of Emmanuel and the engineer. And there's no problem with that. It's perfect. But he still has a job. And he has more time because he can do more complex stuff. Because your job now will not be to learn Unity and do all that thing, get into this programming deep. You can use a higher level interface, and that's where it connects the engineer with you, with the researcher, so that all the complexity, richness of Unity can still be powered, but you use it, control it, put it in modules which you just put drag and drop, not knowing how complex and how many weeks of work the engineer has spent behind. And you're just higher level modifying parameters and saying, if this is this condition, put it blue. Is it also?
Yeah. It's just it sounds like magic to me, but I don't understand what happened inside. But
yes, I think hands-on is useful to grab maybe what exactly you can do.
Yeah, the idea is not to put anything under the carpet, but if you don't want to look at the carpet, you are free to do that. But yeah, it still allows you to do very complex things in a bit different way. it doesn't, yeah, it doesn't limit you. Just make a lot of things easier. Some other things maybe a little bit harder, but I think it's a nice trade-off. You will see it. So I was like, okay, when you have created your flow, and when you select a routine, you can see the different routines. Each routine contains different conditions depending their position in loops. Here, only one condition because it's not inside a loop, so the default one. Here we have, I think we are in the block. We are okay. We are here in this routine, baseline routine, and we are only in the block condition. So we have only one condition, and here you can see what defines this condition. So you have the duration. So when we enter to this routine and to this condition, it will last 60 seconds if you don't do anything to short this line. So here you can see to the left part the different components we have associated with this condition. So basically, we drag and drop components from the left to the right. And with this, we can choose a configuration from this component. Meaning, let's say, take a small example. You have a cube. We have 3 different configurations, and which one it has a different color. I can just drag and drop it and say, okay, this cube in this condition will be red, and this over it will be blue. You can see this script is using the low trigger condition, and the others were using standard condition because we only have one. And here to the right, we have the connection part, but I will speak about that later. So yeah, started, I call it action. When you associate the component to a condition, create an action. It gives you a timeline, so update and visibility. Depending on the components, you may have no sense at all, or logger. We don't need to show it, so it just has an update. Meaning, if it's not enabled, it will not log stuff. And for an asset bundle like this, you only have a visibility because there is no specific logic. So if we just put it in the red, we can. It will not. Okay, I have a short example. It will not be displayed. So here we are just doing a quick example of actions. So what I'm doing here, I will create a routine. I create a component. So I'm choosing, I think it will be a cube. Okay. I drag and drop to the default condition of the routine. I load it to the display launcher. So here we can see I just display a cube. So that is a debug view because the RCD is inside. I open the parameters window of the cube, and we can and here we can show the many parameters. Here is the transform. So the big thing is you can change parameters in real time, not like CircuitPy and ExVR, or you had to reload every time. The designer and the experimenter, they communicate in real time by using EDP, meaning they give you information back, and you can just start it and build your own scene only using the components and without even having to open Unity. Okay, so you can show a big view of timelines. Yeah, in the Blink viewer, it starts by red, so it's not enabled. And after we go red, so the update function will be called, it will be visible. So I think for this script, we don't update it until 4 seconds. We can, from the interface here, we can choose a config. So if a component has many config, they will be displayed here, so we can choose it. You can change the order. You can have some shortcut to modify the timeline. So, but by left clicking, you put it in green, and by clicking, you put it in red. You can change the scale and the resize of everything, and you can reduce. If you want to more space to see stuff, you can just reduce the component. Okay, now we'll go through connections. In one condition, so you can have as many actions meaning components linking to this condition as you want. But you can also define a visual connection between these components. So it's a visual scripting part. It's the thing that make you not mandatory to learn scripting. So it's another window. So here you can see a small. So here I'm bringing a keyboard and a logger in the first routine. I'm changing the size of routine. And here in this part, it's a grid in which you can add different nodes. And you can also add a node, a component node, meaning if a component has some way to communicate with others, it will be displayed here. So we can see I will add a reference to the keyboard. So meaning each time the keyboard will be a key will be pressed, and if the timeline of the keyboard, the eidetic timeline of the keyboard is on, it will transmit signal. So it will transmit events. Oh, okay. For the right, so you can see we will create another node. This one is check keyboard button. So as its name say, it will just send information if the corresponding key or the space key is pressed, and we will be able to get the done millisecond time. So meaning, yeah, I did another next routine. So when we press the space key, it will send this message. It will send the number of milliseconds, the time, the done time of this the key. It will send to this next routine thing. So it will just say, okay, now we are done with this routine. We don't care. We don't need to wait 60 seconds on the full duration. And here we are just using some node to display the results. And I'm linking the logger, so meaning we will write the reaction time in the logger just by using a few nodes. So here I just click on plane, and I just click on space, and you can see after 2,367 milliseconds, it just writes this number in the logger. So it makes things quite easier for linking components, linking data. Here we were able to link the keyboard, so in the inputs from the user to the logging system.
If you choose write, just write, you can create a line from many events.
Yeah, if I don't put
you choose the right line, but so it creates a line indicated for this.
Speaking about the logger module, you in your example you show right line.
Okay.
If you choose right,
yeah, just some components for adding a backslash n after your date. Yeah. But it just it will just add the numbers. We want it.
Just as an example again, so you as an experimenter know which key you want, what to measure, reaction time, now, etc. So that's what you can all do without having to know anything else of Unity, 3D, VR, which is already what you should do in PsychoPy or ePrime anyway.
So this way, it's also quite fast for getting keys. If you know about Unity, it's calling on the onGuy function for getting the inputs. So it's the fastest way to get inputs from Unity. But in very particular case, we may need a very accurate timing for inputs, like in MRI for trigger and stuff. So we have another way. You have another settings, meaning you can get key even if you don't focus on Unity, on the experiment launcher. So you for the MRI at Campus Biotech, it just sends a 5. And for getting it, we need a keylogger, in fact. So, and it's exactly what it does. We can set a setting, we give a keylogger, and it will be, I think a millisecond accurate, maybe even less.
So you catch input from the ExVR.
By default, you will need to focus, it's specifically for keyboard. You will need to focus on the experiment launcher window, like any video game, any software. The key will only have an action on the current software you're using. But by using these settings, you can get kit, even if you are not focusing anything. It can be a bit troublesome if you are writing stuff and user press a key, it will be written on your settings. But it's a thing.
So in terms of, since we are talking timing, the temporal resolution of various events, the errors like that you get, what order or magnitude are they?
For the errors, it's another system. We have I will explain a bit later if you want. I have a slide for that.
But like milliseconds, half a second.
You're speaking about errors or about trigger?
You know, it's three things. You get subject responses, and in your case, you also simulate like respiration. So I guess you need quite some temporal accuracy when you are
for the
synchronizing different things.
for very specific stuff like breathing using the biopack, we are using a dedicated loop for getting data using very low level functions. For the keylogger, it's very particular because basically it's a very low level loop that will check almost every time that the key happens. We can do that faster. I think it's what we are doing in EPRIME and kind of stuff, using the keylogger for getting having the maximum accuracy. And when it's important, like for physiological data, we can use this very low level loop to get data, and it's synchronized in a way that we will have the real timestamp. But most of the time, you don't really need it. You can just send trigger using parallel port, the classical way. You know exactly the time because I'm using very accurate timers when I send triggers, so we can get this time to synchronize your data with our system. So
that's what, microsecond, millisecond, second?
It's I think it's it's hard to say, it depends on the system, but it's millisecond.
And the fact that, sorry, just
finish,
the fact that you may have a very complex scene to render, does it slow down the process? If
your frame rate is still good, and your UC is not at 100%, it's will be okay. You can if your GPU is not lagging, you can just check using the task manager. I have a small indicator in the experiment launcher too. But if there is a very important loop, so we have priority to getting data, and they work in a separate way than the graphical feedback. Meaning, you may be lag if your computer is too slow for what you are displaying. You may lag a bit in VR, but if you don't lag too much, your data will be okay. But it's better to adapt in function of what computer you have.
Yeah, so you had cases where you had to compromise, I don't know how many people.
But in fact, there's not that many ways we need very, very accurate, very big accuracy for putting inputs. But what I'm doing for the keyboard, for mouse and trackpad, we can do way better than having one guy Unity function getting the very accurate, the best timestamp we can have. But when I was linking to the briefing biopack, it's an exception because we were, in this case, we need the data to modify our experiment at real time. It doesn't happen often. It was super complex to create. But no, the component is done and you can use it. So this one is very accurate. We have been using for years and thinks of it going into a publication. So and for MRI trigger, for the keyboard we check, and it was the accuracy was acceptable for what we wanted to do. And but for the rest, you don't need to synchronize everything. You just need to know exactly the timestamp at what you are doing stuff. And after, you can have you will have your timestamp. You will know what you are doing, and it's okay. It doesn't need to be to run at a specific frame rate or anything. Yes.
For the moment, it's not clear for me if your experiment launcher can run on its own, or you always need the designer open to control it.
You have a simulator, but you have a toolbar button for controlling it from the experiment launcher. At first, it was a project to make it totally independent. In fact, it's possible. You can keep the designer and it will still run. But you don't have the way to. I don't have automatized way to be sure that if you are using the experiment launcher alone, it will load the good files. But it can be extended later. That is not a big deal. Basically, they are independent each other. They communicate if they don't see each other.
But which one is catching all the events?
It's only Unity.
Unity one.
And the designer, it's only here for generating the experiment, the randomization, and to display feedback from Unity. In fact, Unity will send every time the current. We'll see maybe. Okay. Maybe I have it.
It's already very technical.
Yeah, maybe I will move a bit forward, and we can keep the technical question.
If it's a Unity runtime which catch events, so timing accuracy is like more or less 15 milliseconds.
No, it's better than that.
No, you can't on Windows platform. Because you
I think we have to have a discussion separate for that, but we have 5 years.
It depends what you are doing. In fact,
you have your operating system, which is Windows, and when you run C# application, the threads are managed by the OS manager.
Yeah.
And at any time, you can switch context.
Sure, it's not a real-time computer.
Yeah, and.
This would be, I mean, this is a specific question, and
Yeah,
a lot of work has been done to go beyond.
There is a specific example where I will agree for you for joypad inputs. Yeah, it depends on the on-guide call and can be called like 5 times during a frame. But for the keylogger, I can assure it's better than 15 milliseconds because I'm running that in a very specific thread, getting very low level data.
So you.
For when it comes, I'm using specific thread running in loads.
Yeah.
The
so
minimum
which stick to the same core.
Yeah, we will not change. It's not a cool manager with some stuff, but maybe we can discuss that a bit later.
But timing is very.
And I feel like you're very specialized in this field, so I think I will learn many things.
So basically, you can achieve millisecond accuracy with Windows API, either from C++ or C#. And in Unix system, you can get microsecond, which is really good, but VR is hard to do on Unix. But yeah, in session.
I'm using.
I think we can continue the discussion later, and I agree. That's why we have been working, and that's why we're sharing the progress.
Yeah, it will be a very nice talk. So I'm just giving a quick overview of the different nodes you can use. So you have generators, meaning for creating variables, can be of any sort, mimicking a bit Unity data, vectors, transform, random areas. IDN is a nice way to identify a value to an ID, something for string. And you can link after to other nodes. You have also operators. You don't see it, but when you click on the blue button, you can change the settings in indication between different operator and multiply, divide, and stuff. And this one is a Boolean operator, so you have classic XOR and stuff. And this one is for manipulating strings. So you have a split, add, and remove. Can have different functions. So trigonometry, same thing. You can choose your trigonometric function for that. You can add a delay to a variable using some resource plotting. You can add some counter. So this delay is quite useful because for creating a synchronous experiment. Okay, no, I need a condition with a delay. Okay, I just need to send to get my my image from my video 100 to pass it through this delay, and it will go back 500 milliseconds later. So for doing our full body illusion, it's quite useful. We get the position of the tracking, and we can just delay it easily in a sync condition. We have converters for condense nodes for converting to other types. And we have a link. So this one is this particle. You have a bit like a multiplexer. You can any type is meaning you can put anything. It will just you can just put 4 things into one, meaning you can send any things for this thing. And ID is any value associated to an ID. So meaning we can do different things according to the ID value. It's useful in scripting because we say, oh, okay, I know when this ID is 2, it's meaning it's the float value from this, I don't know, briefing device or stuff. You have triggers, conditional gate, conditional triggers, so you can do quite interesting logic using that. And you have events. We saw just before the check keyboard button. So you can choose expect time, the time since the beginning of the experiment, or can choose say the beginning of the routine. Can do this, same thing for the iPad button, axis, mouse. You can filter for buttons, and okay, and you have different actions. This one is for manipulating the flow of the experiment. Okay, you have next routine, meaning it will ask to the next frame to go through the next routine. So if you have a routine with a big amount of time and you are just waiting for an input from the user, when you get a set input, you can say, okay, go next, and it will schedule the next routine. And that is the overall a bit the same. You can go to a specific routine with a specific condition. We can change the config from a routine. You can stop the experiment, pause it, many ways to manipulate. And display, we have this post-it node that I was using for us. And we can display curves in real time for data. So you can display by like the briefing data from the biopack or other thing you get. So when we click on it, it displays a curve and you can set a few parameters. So it's useful for debugging. You can logger directly in the left part of the program with the logger window we'll see later. And you have also resource. You can link that to a resource and link it directly to another component. And to finish, we have the flow. So meaning we can get information for the current flow, like the current time, routine name, condition. And this update routine is called at every frame. So you can do different action depending that. You can do something depending the condition from another routine. So many different things. So now we speak a bit about loop and randomization. So thanks to Geneva, we have this nice slides. So when you create a loop, and you can set any number of sets you want to create a different condition. Here we have red, green, blue, meaning in this routine we have 3 conditions: red, green, and blue. So you can see that here. So we use this example for describing the different loop style we are using. So we can use fixed loop, meaning if we go for red, green, blue each time, here we have 6 repetitions. So we do red, green, blue. And if we do that for another instances, for another subject, it will still be the same because it's fixed. We can fix with a random start, meaning it will still be the same order, red, green, blue, but it will start depending the subject at another point, very random. Or we can shift by using the instance ID. We'll see later, but the ID behind the randomization in XVR is to generate randomization for every participant in a row, meaning you will have balanced randomization. And after you choose one of the instance file to load and to load your current randomization for your current subject. So we have also classic randomized, so meaning you can have several times the same way, because randomized doesn't guarantee that you will have a balanced apparition. You have a shuffle. This one is the most common use because you want most of the time you want balance randomization. So we have red, green, blue. We have the settings for avoiding to have 2 times the same the same condition. But it only happens if you have more than 2 different conditions, because if you have red, blue, and red, blue, and red, then you can really do think about that. And okay, you have another way to do specific stuff. You can say that you want your red condition to appear 3 times more often than your blue. So this is a ratio. Yeah, the absolute value doesn't matter. So here we see that green will appear 2 times more than blue, and red will appear 3 times more than blue. Meaning here you can see the result. Green is happening 3 times. Red is appearing 3 times, and green 2 times, and blue 1 time. Okay, and yeah, you can also shuffle only once for all your subjects. It can be because you want them to have randomized their condition, but you want them to all have the same randomization. Or you can say, oh, maybe I will just reduce randomization every 2 subjects, because you want to counterbalance things and do very particular setup. So, meaning if you nested loop like this, but you will do 6 times here, but you will go 5 times here, so you will do that 6 times. So, meaning the randomization is made once. It will compute the number of time you need to randomize stuff, and it will do that in a row. Okay, so now we speak about the toolbar. We have at the top here. So it's here that we control the experiment launcher. So we have basic things like new, save as, open for opening the experiment. So they are made by using XML files. So it's just a file that defines everything we have inside the experiment. So also the different routine, condition, component, their parameters, and the flow. That is for starting and stopping the experiment launcher. So it will quite classic. It will, in fact, it will just start the other window and we start Unity. And when you will be done, you will have access to your other buttons. That is very important. It's for generating the instances we just spoke about. We'll speak about more about later, and that is for choosing a specific instance to load. Also, we have this thing that this button we are using for debug. In fact, the go-to button to just try something is this one. It will just load everything with a default instance. And it will always be the same randomization if you don't change anything in the loop. Meaning it's make easier to debug. And that is just for starting from a specific routine until a specific routine, and to start only one condition. Okay. Oh, and that we have a button for controlling. Once you have loaded your experiment, you can play it, take in pause, you can play with a delay. That is useful for debugging if you are alone and you want to put the HMD on your head. You click start and oh, let's start in 10 seconds, so you can see it and try it. And pause, stop. And that is for going next and previous to the previous routine. So it's like the next routine and previous routine node with the solve. So it's useful also for debugging. Most of the time, it can happen that you use it during a real experience. experiences when you are waiting for the subject to be ready in a big warm-up routine. So, okay, are you ready? We can go. Okay, let's go next. Maybe in a more role-play way. That is for going directly to a specific condition. So you select a condition in your whole experiment. You can say, okay, but I want to test this or to go to this part, and it will check in the instance scenario if the condition is called, because if it doesn't part of the randomization, you can go to it. If you have a 6 condition in a loop, but you have only 1 iteration, it will only go for the first one and not to the others. So we're never able to do, but if it's the case, if you take it, you will say, okay, now we are going to this, and they will skip part of the experiment. And you can also display a list with what everything that will happen during the experiment and say, okay, I want to go here. It can be very important for very big experiments like symptoms. Okay, and we also have this button. So for showing the settings window, here we have quite a lot of important parameters we'll speak about later, and the resources manager window. Also, we'll speak about later. That is for modifying the UI. So basically, focus on the condition, on the connection. Or we have if you click on the eye, it will just treat condition according to what happened in the experiment to be sure to follow each time. Because in the connection, the scripting system, it's displaying real time the value. Meaning, if Unity is sending something to a node, it will display it in a designer. I haven't spoken about that. That is for cleaning the logs, and that is for showing the in-game help. Let's say it's a Markdown help with many different things to explain the interface. So okay, well, so let's speak about more about the randomized instance generator. Yeah, sure.
30 minutes.
30?
30.
Okay. Randomized instance generator. So by using this button, we can define our instances. So let's say we have this condition here. We want to generate instance type for every subject, and we have this window. We define the seed, define the number of instances we want, the base name, and we will generate a list of instance type. And after, we will use this button to load a specific one. Meaning, you have a name of your instance. Let's say, okay, today is subject 4, I don't know. And automatically, the program will know this name, and we can use it as a name in your logger, for example. Meaning, you don't even have to change the logger settings during the subjects. Display mode, so VR, flat, and flat stereoscopic. So classic one is VR. Flat is for 2D experiments. So the key is we change the mode of OpenVR, you can know about that. And flat stereoscopic is used in VMRI, for example. It will share the screen between two eyes and render at a specific way. You can choose a monitor, full screen, resolution. We have another, the tracking panel is for the original calibration is managed. That when you don't need to calibrate the VR using Oculus or system when you start, because it doesn't really matter. We will just define, we just know your initial referential when you click on play, and from that we can just decide, okay, we want this referential to be at this place using a camera component, and you don't need to calibrate. You just need to be sure that the variation is configured. So as I told about before, the global key tracking, it's a setting in debug in inputs. I haven't put it by default because it's not an expected behavior to be able to log everything. It's more like a virus, but key. And when for some changes you have to restart Experiencer by using the red and green buttons to be sure. But most of the time you can just reload it. It's like no, it's not on the hand. So you have a resources manager. And beyond that is you need images, text, videos, or asset bundles. You add them in this window, or by using one. where is my, okay, I lost. By using the one at the top. And now, once it's added in the experiment, it will be loaded automatically when you click on load, but you can decide, okay, this asset bundle, I only want to load them once. So meaning when you start free time your experiment, it will not reload it because it's already loaded. So it's meaning you can, if you have hundreds of asset bundle, the first time you load, it will be maybe a bit long, but after it will be instant. But the very nice point with that, if you can refer to this asset using just an alias, and so from the component, the connector, you can choose from a drop list. Okay, I want the image EMJ4. You don't care about the path or everything, and you can just it's an abstraction over that. Meaning you can also you can see for asset bundles. So it makes it easy to add, remove, or update components. You can access this from everything. Here you have your script hierarchy. You have if you have a directory with your script you are using or create your own, you can just add everything. When the script is added here, it will be compiled. So it needs to compile. It will give you errors if it doesn't. There is an internal compiler added to Unity to do with runtime compiling. And the good thing also is to be able to export with a deep copy. And you have resources from all around your computer. You want to share with someone. You click on export. You choose the directory. It will save the experiment file. Create a hierarchy of directory, and we put the resources inside. And so it will refer to as a local path like /resources/images. So it makes it super easy to create a clean experiment from your potential method. And okay, and so yeah, you can see my logger component is using directory resources. So I just choose the data MRI directory. And here for the asset bundle, okay, I need this lab room, so I just choose it. So then, yeah, the idea is really you only take care of resources inside this window, and after you can use it easily, and you don't mind anymore. So yeah, by selecting what we want to load each time, you can have a faster development. Like I said, for the asset bundle, by default, text and scripting are loaded every time. But if you don't want, yes.
Just I never thought about, but do you clean up when you export if there is resources you put in the loader, but you never use in fact in practice? It should not export it and clean up.
In fact, no, because you don't know what you can do from scripting. I can't identify what you are doing if you are trying. It's possible to analyze your script file to say, oh, he's using this image, so I'm not using this image, I will not add it. But okay. Yeah, I think, yeah, if you have hundreds of videos and you are not using them, yeah, I think, well, if you have a dozen of images you are not using, okay, well, yeah. Like I haven't done this kind of control, but could be automatized. You say, okay, I'll remove everything that is not used. Could be on a specific setting in some hidden menu, but no, it's a nice point. Now we go for the app and documentation window. So in many parts of the program, you have the button. Can have access from the toolbar, but also from component. If you click it on a component, you will directly open the documentation of the component, and same thing for nodes. And basically, it's a markdown, a bit Windows-style documentation with a right menu and indication. And it will go. The nice thing that is the same is that is the same using GitHub, because GitHub can display markdown. So in fact, it shares the documentation, meaning if I modify it, it will modify also online. It's a way to not duplicate stuff. You can modify it directly from ExVR. It's useful for me because the documentation is not paid. And so yeah, you have shortcut access to many places. So we have complaint. We will have the description for components and not scripting. Example, yeah, I choose the model component. I saw some sample code to just copy and paste somewhere. You have description of connection, information. I think I need just a few weeks of focus on it to finish it, but yeah, it can be also a pretty estimate. Okay, now I'm going for the log part. So that will display many things, in fact. I have a very specific way to log things from Unity, but everything is sent to the designer to be displayed, because we don't want to display big red stuff at the bottom of Unity. But it's okay in VR because we don't see it, but into the experiment not. So in components, in nodes, you have you can display error formatted in certain way, information. We can use a log function in scripting if you want to. Okay, oh, if I was not able to load this resource, I will trigger an error. And so you have gray color for normal messages, orange for warning, for meaning it's okay, but give a look. And red, if it's red, it will say, okay, you have to fix that before loading the experiment. Because the idea is to not crash during the experiment. Error can still happen in runtime because it will just compile your scripting. In fact, it will not check that it runs. If you run your script and you have error because you are trying to use some variable allocated to null, it will be up to you to fix that. But yeah, the idea is to have the maximum number of information to help your life. So saying, okay, but this device is not connected, so I will maybe not load. Maybe you should take that before. Oh, yeah, at the line number 64 for this file, you have some error typo, so fix it. So you can change the log with this stuff. As for Unity, don't log too many things. If I don't remember, I should put a limit, but if you log 100 of lines at every frame, it will slow down a little bit. Okay, and so the logging system. I spoke about the global logger before. So the idea is to record other components from this one and to say we have different categories: input, network, UI, tracking. And okay, if I add it to the list, I will say, okay, this component will take care of logging what this component has to log, but it will add data in different files from it in two different ways. We have this part I will speak about it. Okay, we have events like when a key is pressed down or up, and you have a state when a key is actually pressed. So they have been separated different files because for events you care about the timestamp, but the one we use for synchronize every data. And for the state is just every frame I'm logging relevant information. So you can add different components. If you are, it can be a state of the slider, it can be a network, it can be messages received from through the network, like parallel port events, and we are using every time the same timestamp. So it's using the best we can have from Windows, obviously. And also, by default, it will in the SP panel, it will log a number of different things. Just as you can just uncheck if you don't want it. So at each frame, I think. So current routine, current start, duration, number of relevant information, position of the HMD, calibration, frame rate, just so you know, let this not be at the end of your acquisition data with your subject, I should have logged this thing. So by default, we log a lot of things. It doesn't take that much space, but... and you can check it. So this component, we can't add it to a timeline because it's just when you start a new experiment, it will just create it by default. It's just you can remove it if you don't want, but it's usually a nice idea to keep it. Okay, and so you can link this logger over loggers to using the connection system. The loggers are more basic. It's just write what you send to it. But we have one that is specialized in column data. It's particular for CSV thing. And here you can see I have a script function saying, okay, I want to log using this value to this column in some script. Okay, and at the end you will have this kind of files in your data directory if you have defined one. Okay, now we're going to, okay, almost done. So we also the experiment state part. Basically, we have various information. It differs information regarding the current playing experiment. To the left, we have the experiment launcher state, if it's started, either loading or not. We have the experiment state, if it's loading, running, or pause. So here you can see it's running. The current routine, and the number of iterations. We are in the big routine. We are in the block config condition. It's the first time we enter it, and we are at the 16 routine up to 576. So that is useful for the researcher to say, okay, I still have 1 hour, 1 hour, and you can see the current progress bar for the current routine and the total time elapsed. Okay, and I already spoke a bit about C# scripting. So once you have added your script to the resource manager, you can create a C# script component. You just say, okay, I want to instance a specific class. So this class has to follow some pattern to inherit components, but you can generate a template script directly using this button. After, you can just open it and modify it easily. You choose the name. Depending, I haven't spoken about this different panel, but for each component, you have an initialization config and condition config. Initialization config is when we load, meaning it will load stuff that is heavy, or we need to load once most of the time. And in condition config is where we can create different conditions, and mostly it's parameters we may want to change between two conditions. So, but by using this C# we can create inside ExVR different UI. We can just add, oh, I want a checkbox and I want a slider, and we can get this value from the scripting. So if you want to create a script but give it a small interface for the researcher, it's quite useful. I say, okay, I will parameter. It's a parameter for the arena of the previous experiment we saw. As you're loading different files. Oh, and same thing for the condition config. If I want to change to offer value speed, because as an engineer, you don't want to specifically want to spend hours of fine-tuning parameters, because you don't know most of the time more than the researcher what he wants. So you can offer settings and help the researcher to get exactly what he wants. Yeah, and this interface is saved in the XML file too. Okay, so here you can see the basic file you get. So it inherits the specific class, and you can just inherit the different functions. I haven't spoken about in this presentation, but it follows a bit the flow execution pattern from Unity, but with some other classes. For example, you can the slots for getting input value from nodes and many things. But most of the time, you need to initialize, you need to update, and that meaning we call every second. Oh, and then you have many helper functions you can use directly from it for logging stuff, getting time, getting information, and for C# scripting, we have some input and output by default. So it's just any, because we don't know what you want to do. So if we send the data for the first port, we just increment the slot one and convert the value and use it. Okay, and now we are going through the experiment launcher. It's almost done. So Unity version use is the LTS 2019 as a base. It is to generate the experiment at runtime. Each time we click on load, it will erase everything and reload from the XML file. it's an empty shell a bit. It just contains just a logic. There is almost no assets, no resources, no. It's quite empty. This is the logic that it will get from runtime. Yeah, as it runtime, that it will load resources, create components, create different timelines, and we use a Excel file generated to do this kind of things. The instance file will be used to create what will happen. So you say, okay, next routine we have to load this component, we have to use this component and this one, and it will last this amount of seconds. We'll have this connection, and after I go to the next routine, it will close some connection, remove some components, add others. So it's a tedious part. You don't want to code, in fact, and everyone is coding again and again in MATLAB and Unity every time. And it may be good, but most of the time they spend months fixing weird bugs and stuff. So, as I said, there's very little communication with the designer. So they both send information from the designer. It's mostly comments, and from the external console, it's mostly feedbacks. So you can see you have a bit the same toolbar. You can hide it because in VR you will not be able to see it, but it's useful for the researcher to manipulate because you don't want to. Sometimes you only have one screen, or easier this way. But if you want to do 2D flat experiment, you can hide it, so the user will not be able to see it. So okay, so there's one nice thing. Here we can see we are loading the experiment launcher inside ExVR. Okay, so it's classic. We just load and we just click on play, and we start up the experiment. But if you are using Unity, you may want to debug directly in Unity, in fact, because from the GitHub you can just open the Unity project, the Experiencer Unity project, and you can link it also with the designer. Okay, meaning here I have the Unity project launch, and if I start it, it will automatically try to connect with a designer. So for the designer, it will be exactly the same. It will still do the same thing. So we are loading again, but from the point of view of the user, the developer, you can have access to the inspector of Unity, and you can try things, modify stuff, see profiler, do debug things. So that is the best way to develop a complex experiment when you are using Unity. You can just see the different things. You can use the debug filters of Unity. Okay. So I'm doing that every time. As I'm using the build version as a model test, but it's not mandatory. Also, you have a stable view at the top of the experiment launcher. You have this button. It's for displaying a debug camera. You can move, because by default you can't move the camera because it's fixed to the user HMD. Or if there's an HMD, or if there's no HMD, it will just never move because it's just a fixed point in space. But you may want to inspect what happens. So when you click on it, it will display a top, bottom, left window. You can manipulate with the mouse and you can move everywhere. So make it easier to navigate. So we can see here what the user is doing because we have a small VR SMD model. And here is a full view. So here, as you displaying but for you, the user, you will still see what happened. You will not see this camera. That is only for the researcher. So you can manipulate and make it easier to try and create other things. Oh, I think we just reached the end. So it was a bit long, but I think I can answer any question you have.
Rich of pictures, huh?
Yeah, and while doing that, I just understand. I forget to speak about that, but yeah, it was a bit dense. Sorry for that.
maybe some people might use it before.
So I have
Sure.
various types of. So you showed us a little bit what happens the day of the experiment, how you want to know where we are at on. So just to make sure I'm understanding it right, the day of the experiment, you will launch the same software that you use for developing the whole thing, right? For example, I'm comparing with Unity where you can generate an exe file and then you don't need the whole thing the day of the experiment. But here it's the same software that runs the experiment and develops the experiment.
Yeah.
And there is no option to generate a standalone thing that is set around or there is.
If you want to, for
I'm
now,
afraid
no.
of if, you know, tomorrow a pandemic hits and we want to launch the experiment to somewhere, to someone somewhere in the world so that he or she can play.
So we
with
do
something.
that.
You can do that.
But indeed, it was something we discussed, but I said, oh, but then there's too many buttons to frighten the user. And well, it's something we could still do, that just, and I think you.
We have some example, but we are doing fine for now.
But we are sending XDR, the zip, people double click, and the instruction is file open, press play, and they are doing that. So finally, we ended up saying, well, why should we make our site more complex when in practice it's file open and play?
But yeah,
Really nothing. So the psychologists or medical doctors in West Virginia University or in Stanford University, they just press play. Okay. So, but I understand the point. Could be that we hide or make.
it's totally possible, but as it may remove way more control to the experimenter. I wasn't that trying to do that. Especially if you have an experiment, you need to go next to see exactly or 2D experiment. You need to have access to the control. But if you have only the window, the user is saying you can't interact. So it can be it's totally doable and maybe an option in the future, but for our experience, it wasn't very useful.
Yeah, no, I just have two cases in mind where it could be useful. First, if you do everything online, like you said, only a behavioral experiment, you send it around. So the person receiving it has to install the software, is that correct?
You
Extract.
You uncompress the zip file.
Okay, you send a zip file, then they install and run.
No, it's fine.
Uncompress
So this is already something in place.
There's no installation requirement.
Okay.
So it's just directory.
Okay, so the other case that I think such a feature would be useful, for example, at HUJ, you cannot install any software whatsoever.
So you run that on the local folder. You can
exactly.
copy in the local folder,
So
user, double click.
and you don't need Unity therefore to
No,
run it.
you don't.
In fact, you can even put it, let it on the USB key. But not, you still need your experiment content to be accessible from reasonably fast hard drive. But yeah, it's just a directory. It may ask for some firewall authorization if you are doing because with some communication, but yeah, it can work on non-admin PCs. But I can't say for sure, depending what you are doing with your experiments. If you are doing some networking, yeah, it will ask you for authorization. So, but it will be the same if you drop. That is exactly the same. We drop not only the experimenter but the designer too, but because it gives you more control. And yeah, but it would be the same to replace. We can replace this designer by a small command line program that what do you want to load? Type your file, or we can just automatically load the experiment close to it. But nothing is very satisfying. That's something for me. So, but yeah, it could be an option. it's not very hard to do. It's just
But you're already engineering it, so next question.
I don't want to take this, if anyone.
there is no.
Any others? Maybe go with
Curious with results because we have the workflow of the whole experiment, but sometimes we may need maybe insert some resource like of lag, that's something you want. Can we just download the resource from the Unity website, the open source resource, and input everything into the workflow, or where can we?
So you want to use some stuff from the asset store?
Yeah.
You need to pass by the Unity asset bundle step, but it's quite easy in fact. You open Unity, you open a scene, you just select what you want to keep inside, and I have a script. I should add it to the GitHub too. You can add this script to any Unity project, and it will just add a menu saying, okay, create an asset bundle from that with this name. But you can do that directly from the interface, but the Unity interface is quite bad for this part. So I did some custom script for doing that, but it's very easy. You just drop your hierarchy to the left panel, and we create a prefab for that. And the prefab you give a name, and you should build asset bundle for prefab. So if we create asset bundle, we just set the name you set, and you just build it. You will have a lot of different files. By default, I set a new extension because there is no extension for default Unity asset bundle. So it was a bit hard to manipulate. So I created what was the most common used extension from the internet for asset bundle. So I think it's Unity free asset stuff. We go back. Wait. Oh,
But I think it's clear.
Yeah.
The answer is yes. The short one.
I don't like short answer, but every that you need to, if it's using custom script, meaning script that doesn't exist in the bare Unity, and then you have defined new classes, and you are using it as model behaviors. You need to remove them and to add it using the C# script. There is another way to do that, but I haven't put it in this session. In fact, I have a way to serialize every script you are using in your scene. It will just say, okay, I will replace this. I will have to, it will remove the component, replace it by a component that say, I will have to instance when you will load some Unity asset bundle, it will detect this component, saying, okay, this component I need to remove this component to instantiate the real one. But as it happened after we have loaded every other C# script, we have no access to this class. It exists. Before it wasn't. If we did that in the wrong way, we weren't able to load it because we don't know this class. But as we just compile it, we can replace it by the normal one and say, okay, that's good. But yeah, it's a bit power user stuff, so I haven't spoken about that. It's another way, but I think once you get a bit used, it's better to directly script from XVR, from the Visual Studio, but I to the XVR scripting, and to do the content, only the content in Unity. But it's up to you. You have some options. Sure.
So my next question is very general. It's about the durability and versioning of your open source thing. Let's say you release it today, tomorrow you find out there is a bug, and the day after tomorrow there is another person in the lab that develops a new feature. Are you versioning it, or is there a little community, interactive community to talk to? How does it work?
It's an important thing to say that. I will finish my job at LNCO today. It was my last day, in fact. But the project is totally open source, and I will be glad to continue it way or another. And we have other people in the lab who are able to add features, to fix, I think, most of the small bugs. But yeah, I think the whole design is quite bug resilient. Just the designer, but after the content, what you want to add, new components, new nodes, maybe another thing. But yeah, I suppose Blanca Lab will continue if they find some bug, or if there's some revision ask from the GitHub link, they can just check if they can implement it and do a commit to the main repo.
So that's a very good question, and that's a bit the reason of today. And that try to switch from everything depends on the knowledge of one man to the community who keeps maintaining a tool which was built after years. We hope Florian will keep, as you say, one way or another, we'll see, involved heavily, but definitely. That's why he shares with people from the exhibition activity came, not today, but another workshop before, and we're very close to them. And then, of course, and others, maybe beyond. And the idea being that, well, it should be a living software which evolves hopefully.
If I fork your GitHub repo and I do pull requests, so tomorrow there is someone which handles this request.
Tomorrow, maybe not. But the day after tomorrow, yes. No, but true. That's exactly the idea. And the documentation for compiling the source we made. We didn't think of that today.
Yeah, there is a different part. You have the designer part made in C++, and the Unity part, the experimental part made in Unity. So for the Unity, you just need to open the project with a good Unity version. So it's not a big deal, but to compile the designer is more complicated. It's 500,000 line code project. So, it's quite easy. It's quite easy, in fact, using Qt, as you can guess from the interface, and using some very big Qmate hierarchy of projects. Basically, when you see the instructions, you say, "Okay, open this project, add this kit, and click on compile." It should work. But what I wanted to say is the interface, I don't think it will change a lot, because Psychopile doesn't change its interface every day, and most of the core functionality are here and available. But I made the insert that if you want to add content, so new component doing new things, it's a very particular part of the code that you have to. You don't have to go deep into the code. You just have go to this place, create a new file, add it to the project, add with reference to the component, so you can look to other components to know, or I may generate the different interface. So, but I think it's quite. I have one here, maybe. Okay. Okay. In fact, everything you see here is just defining code. It's not using visual UI. So you just say, okay, add a component, add a combo box, give its name, give them the value, align it with the interface. It's just I can create a component like that in 10 minutes. Well, I'm used to it, so, but it's not very hard. And this thing is only it's managing the way we save the data to XML file, the way we adapt it, we send it to XP launcher. But what you only need to do is just to create your different UI elements, give them some ID name, initialize them. You have just two different functions to inherit, and you add your new component in the list in some other file. You compile it, it happens. Or you may need to add a new icon and stuff, but you can.
You don't have to deal with the Qt.
Do I have to what?
No, we Qt and C++.
It's C++. You have to code, but
To generate a new component, you have to deal with Qt code directly.
you use my code that deals with Qt code.
Yeah,
But yeah,
but
it's,
I don't need to.
to know about Qt, no, you can just guess from looking at other components what happened. You just copy the base components. I may add a documentation about that, but that is really for the designer part. For nodes, it's a bit more complicated, but as we can just link them to script, or we can add code in some nodes. But doing a fancy node is complicated. But doing a node with some input and output, not especially any settings, it's easy to add. But a bit more complex by components. Because yeah, this part was really hard to code. But yeah, I made it also that the important part for adding new stuff is easy and well identified. And from the Unity side, you just have to create a new component inherited by some master class, parent class, and you can also look at the others to give you but yeah, you create a new component and you do what you put inside.
It's meant to be available.
Yeah. So it can evolve easily by adding more components, adding more nodes, maybe more resources, but it's a bit more tricky. But adding new functionality in the interface, yeah, it could be, but we'll see. But it's another thing. I need to know a little bit about the Qt.
People are hungry.
Yeah, it's a bit late.
Yes. So thanks again. So it was a bit intense, but there was a lot of content to cover, and I planned a closing remark that just the lunch is in front, and the cafeteria and the room separate on Saint-Apel. Actually, this happened.
It's here. Nice.
So I thought it would be standing below, but they put us in the room over there, so we can keep. And then we come back here about the sea when we done lunch at around 1 something, so that we have time to do the exercise till 3, and we have time to continue the day, email and all the rest. And before the end of the day, and yeah, I think you will understand many things by clicking and doing.
It's very easy and in keep it. It's not hard at all.
So who needs a computer? You know, one, we need one.
Oh, okay.
Three. When you can. No, it's a matter. You can read the manual.
Thank you.